What's going on, everyone? You're back with your boy Jono for another quick math lesson. Today we're going to look at how to operate with square roots. So we're really talking about adding and subtracting them. And you're going to find out very quickly that perfect squares are the most important part of this. So you absolutely have to know your perfect squares. So if you do need to rote learn them, it's definitely worth it. So it's just these ones. 1 squared equals 1, 2 squared equals 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, all the way up to 12. So you do need to get these in your mind, otherwise this topic becomes way harder. The reason that these perfect squares are so important is that a square root of a perfect square gives you a whole number. So the square root of 16 is equal to 4, because 4 times 4 is equal to 16. But then the square root of a non-perfect square, for example, the square root of 5, gives you what we call an irrational number. So this is a number that's not whole, and its decimal just goes forever and ever. So this one, because it's greater than the square root of 4, which is 2, and less than the square root of 9, which is 3, we could guess that it is going to be 2 point something. And for this one, it's 2.23, blah, 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 blah. The reason that this is important is we can actually use these perfect squares to work out a whole bunch of stuff about adding square roots. Because we know that the square root of these perfect squares is going to be a whole number, we can check our answers really easily. So let's have a look at these two examples. We've got very similar looking equations, and we need to know whether or not these are the same. So the square root of 16 plus the square root of 9. Square root of 16 is 4, square root of 9 is 3. So this becomes 4 plus 3, which is equal to 7. But if I tried to do this in one step, like in that bottom one, where I've gone, oh, they're both square roots, I'll put them under the same root, that would become 16 plus 9, which is equal to 25. So that square root of 25 would be equal to 5, which is not the same. So the takeaway from this is that we cannot add roots together, right? We can't put everything under the same root and go, yep, that's perfect. There are rules that we have to follow. And the rules for this are, if it's under the square root sign, you have to do this operation first and then perform the square root after. So the way that I like to think about it is that there are brackets under the square root. And if you remember BODMAS or BIDMAS or whatever, the brackets is the first operation you always have to do. So for this, I've got to do the 100 minus 64 first. So that is equal to 36. So now I've got the square root of 36 divided by 9. Square root of 36 is 6, so my answer is 6 over 9. And simplifying fractions, that becomes 2 over 3, done. So just doing that initial bracket first is really important. So then for this one, because everything's under the square root, I've got to do that bracket, the entire thing, as my first step. So 100 minus 64 is 36, but that's divided by 9. So that means that 36 divided by 9 is equal to 4. So I'm left with the square root of 4. Square root of 4 is equal to 2, and then you're done. So I know this was a really quick lesson, but it's just an introduction in how to use these square roots effectively. We can't just add them together because they look like they're the same sign. We have to make sure that we are following the correct set of rules, just like in every other kind of maths. Thanks so much for watching this lesson, guys, and I'll see you later.